Okay, in this AC and ventilation system design calculation, we have seen from beginning like architectural package, then the design based report, how to prepare the report based on the calculations whatever we have done so far, right? And the HVAC room data sheet, which includes all the input parameters, okay, for the ventilation, for the air conditioning system, for the smoke ventilation, we have to provide the input to get the output, okay. Then we have seen codes and standards, okay. There are many codes and standards like local codes, then there is international codes which we have to follow for our calculation purpose, clear, right? Then we have seen the HAP calculation, okay. Before the HAP calculation we have seen that what is a psychometric chart, okay. Then we have seen ASHRAE guideline, how to take the parameters, right, the weather parameters, okay. Then the HAP calculation we have seen in the manual method, okay. Then we have seen what is external load, what is internal load. So external load comes, what are the category, then internal load comes with what are categories, okay. Then how to calculate sensible load, how to calculate latent load, right? Then we have seen that properties of the air such as like a dry bulb temperature, wet bulb temperature, okay. Then we have seen relative humidity, what is relative humidity, enthalpy. We have seen the complete psychometric study, right? Okay, now before we start into the HAP calculation, okay, the purpose of the HAP calculation is to get the capacity of the equipment such as like a fan coil unit or air handling unit such as like cooling equipments, right? Okay, so this particular result you will get total load, sensible load, then the airflow rate, okay, what is the on coil temperature, what is off coil temperature, okay. Then what is based on the design condition, we will get all the parameters, right? So based on that parameter you can able to prepare the equipment schedule. Basically when you go to the IFC equipment, when you go to the IFC package, you have a equipment schedules like for HVAC equipment such as fan coil unit, AHU, FHU, then you have a ventilation fans. There are different type of equipments, okay. So one of the equipment is a cooling equipments, which is fan coil unit or air handling unit, okay. So in this particular calculation we will see based on our local regulations, right? Okay, how to prepare the input based on the local regulations, then based on that we can able to extract the output, right? Okay, say for example if you go to local regulations, okay, one of the chapter, you can see this is, we have seen the design criteria, right? Like how to calculate the, how to take the U value for roof, U value for the external wall, okay. Then glazing factors, right? Then after that what is the design condition to be considered for the indoor and outdoor, okay. Then what is the safety factor to be considered, right? And what is the lighting load to be considered, okay. So there is a lighting power density. So all the parameter is given in the UA, in the regulations, okay. As an example I will take one of the layout, okay. So assume that there is a studio building, I have taken one of the building for our calculation purpose, right? Okay, if I open one of the HAP software, right? Say for example this is the one of the sample calculation which I have done so far, right? Okay, if you go to input data sheet, okay, assume that this is the serial number 1, okay. You have to prepare for all the rooms to get the total load, right? Say for example you have a project with the multiple floors, so say for example ground floor, first floor, second floor, then you will calculate the total project load, right? Based on that you can able to select whether chiller or cooling or water cooled chiller or VRF system or DX system, you can able to select, okay. Now depends upon the capacity, you can able to select which type of equipment you are going, right? Okay, as an example you see this is the block A, okay. Then the floor reference is ground floor, then location is studio, right? Then you can see the floor reference, floor area, which is 28 square meter as per the layout, right? This is, you can see here 27.73 square meter, okay. So as a round off I have considered 28 square meter. Then based on the local regulation, okay, the temperature should be considered 46 or 29, okay. But if some of the client will ask you to consider based on ASHRAE parameters, if you go to ASHRAE stations, ASHRAE meteo.information, okay, if you go to station, assume that you are in Asia, okay, then United Arab Emirates, then assume that we are in Dubai, okay. From here you can able to take the parameters, which is the maximum extreme annual temperature. What is the maximum temperature? 46.3 and 31.5, okay. This is based on ASHRAE guideline, okay. But if you go to based on local regulation, they have asked us to consider 46 and 29, right? Based on the local regulations here. You can see 4629. Okay. So first we are filling all the input parameters. Okay. Like a block is a block, and what is the floor number, and what is the type of building, okay, floor area, what is the ambient temperature. If you go to psychometric chart to find out, remember we have seen there are lot of properties of air, right? Like dry bulb temperature, wet bulb temperature, relative humidity, enthalpy, okay, then specific volume, humidity ratio. We have many parameters, okay, but if you know two parameters, you can able to get other parameters, right? So for that, as an example, if you go to psychometric chart, okay, you can able to enter dry bulb temperature and wet bulb temperature, which is 29 degree. Okay, you can calculate other parameters, right? Like relative humidity, dew point temperature, absolute humidity, enthalpy, specific volume. You can able to calculate other values. Okay, so here relative humidity, to understand what is the condition of the air, whether it is dry air or it is a humid air. Okay, to understand the condition, we are just entering the value here. What is the relative humidity, right? Okay, then the floor area we have already calculated based on the layout. Then the ceiling height. Assume that the ceiling height is 4 meter. Everyone know that how to take the ceiling height, right? We have seen the architectural package. Okay, what is the minimum height requirement for the office building or for the residential building, and what is the attic space required? Okay, assume that 2.4 is the ceiling height. Okay, from false ceiling to your floor or clear height. Then you require 1.6 meter or 1.2 meter required for to run your MEP services. Okay, so this is the total height. Clear, right? So then the lighting load. Lighting load, if you go to regulations, okay, how much they said to consider for the different type of category. Okay, you have a commercial building, offices, hotel, resort, restaurants, educational facilities, manufacturing facility, a retail outlet, shopping malls. Okay, you have a different type of categories. Okay, so you have to take what is the maximum average watts per square meter. If it is commercial building, 10 watts per square meter, retail shops, 14 watts per meter square. Based on that, you can able to provide the input. But if you go to Abu Dhabi regulations, okay, you have a more categories compared to Dubai. Okay, see that lighting power density for each and every type of buildings or type of rooms, you will get the total lighting power density. Okay, if you go to commercial building, okay, commercial building itself, you have a different types, right? Like you can see parking area, parking garbage, then post office, okay, then bedroom, okay, dining room. So here it is all provided. The value is provided with more breakdown compared to Dubai. Okay, so you can able to fill the value here. What is the lighting factor as per Dubai? It is 10 watts per meter square, right? Total lighting load will be area multiplied by lighting, 10 watts per meter square. So you will get total lighting load. Okay, electrical equipment load, it is nothing but, say for example your residential. Okay, the heat dissipation comes from where? Comes from socket, comes from cable, or you have a PC, laptop. Okay, if you have any other electrical equipments, electronic equipments where the heat will be dissipated. So that value will be approximately, if you check with your electrical engineer, he can give you the value approximate like 10 watts per meter square or 15 watts per meter square. Okay. So whatever the value we can able to consider in our calculation purpose, because the heat will be dissipated inside the air conditioned space. So the air conditioned equipment should capable of absorbing that heat dissipation from the equipment, right? Okay. Then the next one will be the people. Okay. The people calculation will be based on the two methods. One, either you can calculate based on the furniture, or either you can calculate based on the ASHRAE. Okay. ASHRAE 62.1 regulations. Okay. If you take as per the furniture, okay, if I go to one of the layout, okay, here I can tell you that how many people can be living in this area. Okay. Assume that this is a studio flat. So maximum like two people or three people can be living in this area. Okay. So you can consider three people. Clear, right? Three people. Okay. I don't have any furniture layout. So what is the consideration? If you go to ASHRAE, you can able to get the, depends upon the category, you will get the density, occupant density. Okay. Say for example, if it is a metal shop, it can occupy 20 people can be occupied in 100 square meter of space. Okay. If it is a dining rooms, 70 people can be occupied in 100 square meter space. Okay, so if I see 100 square meters, so what is the per meter square value? 0.7 people, right? So 0.7 per meter square. Okay, if I take this one, 0.2 per meter square, right? 20 divided by 100. So 0.2 people per meter square. So this is the way you can calculate number of people based on ASHRAE. Okay, if you don't have furniture layouts. Okay, then the U value will be from the civil engineer inputs. Okay, say for example, if I go to one of the project, right, he used to calculate the U value, the civil engineers, for the external wall. What is the calculation based on the different type of material, outside surface, film resistance for walls, plaster. Okay, so each and every material having a resistance, right, resistance. So how to calculate U value? U is nothing but 1 by R. Okay, so we know the R value, then from here you can calculate U value, right? So this is the U value for walls, roofs, or for partition, or for ceiling, or for glass, everything from the local regulations as well. If you go to local regulation, here also they have provided what is the U value for the roof maximum. But civil engineer can tell you that what is the calculated actual value. Maybe it is 0.2 or 0.25. Okay, then the lesser the value, higher good for air conditioning, right? You will save lot of air conditioning load if your U value is very lesser. Okay, so lesser is better, right? External wall U is nothing but 0.57 watts per meter square Kelvin. For glazing, okay, different type of glass, you have a values given here, right? So you can enter the value here for the glass. For the wall, 0.57. For the glass, 1.9 slash 0.32 is a shading coefficient. Okay, then for the U value for the door, 2.6. For the floor, 0.3. For the roof, 0.3. For the wall partition, 2.2. For the ceiling partition, 2.2. Right? So this is the input from civil engineers. Okay. Then what is the design condition? I have to design my project based on 24 degrees Celsius air conditioning load. Okay, then the relative humidity will be 50%. This is my human comfort requirement, right? So I have provided all the input now. Okay, if I go to one of the sample HAP software, okay, so here you can see the three parameters, right? One is weather, spaces, and system. When you open the HAP software, when you go to the new file, you can able to see three parameters, like one is the weather, space, and system. Okay, so if you go to the weather, first one, and you are going to select Middle East, then you will select United Arab Emirates, then Dubai. Okay, so here you will enter the value here, 46 and 29. Then the daily range will be 30.8 as per local regulation. Clear, right? Ahmad, Anand, you're clear? Any doubts?
Yes.
Yeah, Soji, you can hear, I think, right? Okay. So then you can see the design temperature. This is the maximum and minimum temperature of that particular month. Okay, you can see the January month. This is the maximum temperature, dry bulb temperature, and minimum dry bulb temperature. Okay, and in the same month, your maximum wet bulb temperature and minimum wet bulb temperature. So this chart is based on monthly chart. Okay, you can see the August month is the peak temperature, August 46 and 29, right? So based on this only, we are designing our air conditioning peak month, peak load. Okay, then you can see the hourly data basis. Hourly means like every hour what is the temperature. In the January month, 4 o'clock, what is the temperature? February month, 4 o'clock, what is the wet bulb temperature? Okay, if you go to April month, 1 o'clock, what is the temperature? So you can see hourly basis. This is the monthly basis, this is the hourly basis, right? And if you go to design solar, okay, here also from the solar intensity, right? For example, your solar will be in the morning, will have a different intensity, and in the afternoon you have a different intensity, evening you have a different intensity, right? So this is based on the monthly wise, based on the direction. Okay, what is the watts per meter square? This unit is very important, right? Per meter square, this much watts will be dissipate, will be having a heat intensity. Okay, assume that in the month of June, your wall direction is northeast, so it can the solar it can gain 570.5 watts per meter square. Okay, so that is the purpose, right? So this value will be calculated will be taken and calculated for the building load purpose. Okay, then you have a simulation. Okay, this simulation is for the to prepare holiday list. Assume that say for example your global village. Okay, the global village will not be operated in the month of say for example during the summer, they will not be operating. Okay, so it will calculate based on the available month, which is the maximum temperature it will calculate. Okay, so that is why we are using this particular chart, but it's not required as of now, because always air conditioning will be calculated based on peak condition, right? So we don't use any of the holiday list. Clear, right? So this is the weather parameters. Okay, then when you enter, it will be taken. Okay, then the next one will be the space. Okay, space, you can see there are general, internal, walls, roof, infiltration, then you have a floor and partition. Remember, we have seen that internal and external load, right? So this all comes in external load: walls, roof, infiltration. Then the internal load like floors, partition, this all will come in internal and external load, right? Then you can see the internal load such as lighting, task lighting, electrical equipment, then occupancy. Okay, then you have a miscellaneous load. So this all will comes in internal load, right? So if you have seen internal and we have seen external. Okay, now you are going to fill the data. Okay, general, what is the type of building? Studio, floor area 28 square meter. Okay, then the average ceiling height 4 meter as per our table, right? Then the building type of building will be light construction, medium construction, and heavy construction. Normally we do based on medium construction because it consists of brick or concrete. Okay, so that comes in medium category. Okay, then the outside air ventilation. Okay, we have a two type of ventilation. One is the treated ventilation, one is the untreated fresh air, right? Assume that treated fresh air. Okay, so this comes from fresh air handling unit. Okay, so the fresh air handling unit can deliver the temperature close to the return temperature, so there is no additional load to the fan coil unit. Okay, in case if you are taking from untreated fresh air from outside, so that means you are mixing with the return air plus outside air, right? So if you go to one of the calculation, okay, if you see the return temperature, normally the mixing temperature, what is that? Your on coil, air on coil will be same as return temperature, right? Okay, assume that you are treating, you're going to bring unconditioned ventilation here. What will happen? That will mix with your return air temperature. So when you see the calculation, your mass of return airflow multiplied by return air temperature plus mass of outdoor airflow multiplied by outdoor air temperature divided by mass of return air plus mass of outside air, right? So this will give you what is the mixing temperature. Assume that I have a 24 degree Celsius return. Okay, and from outside, assume I have 46 degree Celsius. Okay, and assume that 80% of air will be the return air. Okay, 20% I will bring fresh air, right? So this how you will calculate your mass of airflow, mass of return airflow. How much? 80%, right? 0.8 multiplied by return air temperature, which is 24, plus mass of outside air, which is 46, multiplied by outside air 20%, which is 0.2. Okay, divide by outside air, which is 80% plus 20%, right? So you can see that mixing temperature will be 28.4. So that 28.4 will be entering into the coil instead of 24. So that is the difference. Okay, so if you are going to have a treated fresh air, and then your return temperature will be 24. Okay, that will be the on coil temperature. Okay, if you, in case if you are going to take the untreated fresh air, then your on coil temperature will be 28.4 because it is mixing with the outside air, right? So because of hot air, your on coil temperature will be 28.4 instead of 24. So your machine will be designed based on 28.4 instead of 24. So that is the difference, right? So if you go to HAP software, if you don't have any additional load, then you can consider as a 0. Okay, assume that you are having a untreated fresh air, then you have to consider these parameters. Clear, right? Okay, then if you go to internal wall, this is as per the regulations, 10 watts per meter square. For the electrical equipment, 10 watts per meter square. Occupancy, 3 people, right? As per the table what we calculated. Okay, then you are going to the walls. So wall, assume that this is one of my project, okay, where this is the north, this is south, this is west, and this is east. Okay, so if I see the building, this is the building, right? So when you see the west side, this is the west side, right? This is west towards west side. So this is the external wall. Okay, then this is south, this is external wall, right? So these two are external load. Clear, right? So if you go to HAP software, so one is the west side, one is the south side, right? So what is the area of the wall? If you go here, 3.85 multiplied by 4. So this is the external wall square meter area. Then for the towards south side, 8.2 multiplied by 4. So this is the external side of south side. So you can enter the area, right? Enter the area. Then how many window in the west side or south side? West side 1 window and south side 0 window, nothing. Okay, then go to wall. This is for the U value calculation, right? So external wall, and you have to select the type of wall or type of material based on the civil engineer. Okay, if you cannot select as per the civil engineer, just try to match the value, because this value will be calculated to calculate what is the load in the external wall, right? So what is the equation to calculate the external wall? We have seen in the previous class, right? U A delta T. So here you know U, and area you know from the wall, and delta T. What is the temperature difference between external and internal? So with this equation, you can calculate the external wall load, right? How much heat dissipation or how much heat comes from through the external wall. So based on the equation also we can calculate, but the how software, how it calculate, we can able to understand, right? So this is the value. Next for window. Okay, window, what is the value? 2.68 by 2. So if you go to here, this is 2.68, the window dimension, right? So if you go to the HAP software, you can see 2.68 multiplied by 2 is the naming you are giving, because you have a multiple windows with the different sizes. Okay, then you are going to give the height, then you are going to give the width, then U value as per the table, shade coefficient, right? So this is for the window wall. Then the shading coefficient will be default type. Clear, Anand? Agmat, you are clear, right?
Yes, sir.
Yes, yes.
Yeah. Then you are going to the roof. Okay, roof is a horizontal roof. So the roof value will be same as your floor area, right? Okay. Then your roof U value. This is also we have seen, we have calculated based on the guideline, right? 0.3 watts per meter square Kelvin. So you are going to select the material based on the civil engineer. Then you are going to get the value of the U value, 0.3. Okay. Then we have seen that infiltration depends upon the type of construction, right? You have a tight building, then you have a medium building, then you have a heavy or loose construction. If you go to this particular guideline, you can see the infiltration airflow type. One is a tight building, one is a medium and loose construction. If you have a tight building, you have a less infiltration. If you have a loose building, you have a more infiltration through the gaps or through the wall cracks, through the window openings, right? So assume that we consider tight construction, 0.3. So if you go here, 0.3, right? Okay, then if you go to the floor, You have a different type of floors. One is the floor above condition, one is the floor above condition, unconditioned space, one is a slab on grade, one is slab below grade. What is the meaning here? Assume that I have multiple floors, right? Multiple floor here, or I will draw somewhere here. Okay, this is the floor. Okay, so when you are calculating air conditioning load for this particular room, okay, this is slab on grade because this particular room is directly on the ground floor, right? So this is called slab on grade. Okay, what is slab below grade? Assume that this is your ground floor. Okay, your floor isn't below the ground floor, below level. That is like basement. So that is slab below grade, right? Okay, assume that you are calculating this particular room. Okay, so here what is this one? This is conditioned space, and here you are calculating the air conditioning load. So that means this is conditioned load, right? If you go to the HAP, floor above conditioned space. So there is no heat transfer through the floor, right? Assume that you have an unconditioned space. This particular space is unconditioned. This is unconditioned, but you are calculating load for this room. So that means the floor is unconditioned space. Okay, because the heat will be transferred from here to here. So this is additional load. It has to perform, including the whatever the heat will be transferred from this room to this room. So the equipment should be calculated based on that, right? So you have a 4 category. Okay, you can select any of the category here: slab on grade, or below grade, or unconditioned space, or conditioned space. If you choose floor above unconditioned space, that means there is no heat transfer. Okay, if you select floor above unconditioned space, then you have to enter the floor area. Then what is the U value of the floor? Okay, what is the unconditioned space maximum temperature? Okay, that, and what is the ambient space maximum temperature? Then unconditioned space minimum temperature. Then ambient and space maximum temperature. You can enter the value here, right? What is the ambient space maximum temperature? It can go up to 35 degrees Celsius, right? And unconditioned space maximum temperature will be 24. This is what we are going to condition the space. Okay, then the minimum temperature will be 23.49 again, because that is the minimum temperature we are going to condition the space, right? This is based on the design condition. Then space minimum temperature and maximum temperature will be based on the outside condition, right? Okay, outside is 46 degrees Celsius. Okay, but when it comes to the internal, right, when you measure the temperature, say for example, when you go to when you go to the construction building, okay, when you take the temperature from the from the covered space, okay, you are expecting like a 35 degrees Celsius to, say for example, 40 degrees Celsius. Okay, this is the temperature you will measure in the covered space, covered building, not external, not from outside, in the covered building. So you can say whatever the temperature, you can able to enter the values here, right? So similarly for the partition as well, whether you have a partition or ceiling partition, right? Wall partition means assume that you have one floor here, and this is another room, right? So this particular area, this is condition space. Then there is no heat will be transferred through the wall, right? Assume that this is unconditioned, this is conditioned space. That means there is a heat will be transferred from here to here. So this particular machine should capable of taking additional load through the wall heat transfer. So that is why you have to enter the wall partition. What is the wall area of the wall? What is the U value? Same thing, like a space maximum temperature, ambient space maximum temperature, unconditioned space maximum temperature, and ambient at space minimum temperature, right? So this is the value you have to enter. Similarly for the ceiling partition, what is the ceiling partition? Same case. This is here I'm going to calculate the heat load here, right? Equipment calculation, but this particular room is unconditioned. So what is that? My ceiling is unconditioned space, right? So there will be heat will be transferred. So this is called ceiling partition. So this is conditioned space, unconditioned, unconditioned. So this is a ceiling partition, this is a wall partition. Okay. So what is the area of the wall, or what is the area of the ceiling? I will be entering the value here. Okay, this is a ceiling partition, this is a wall partition. Then I will rest U value, what other parameters I will be entering. Okay, is anyone clear? Agamat, Anand, you have any doubt?
No, sir.
Okay, so you
Sir,
can
one
able to
more doubt.
enter.
The
Yeah.
ceiling, sir, one doubt here. The ceiling height you mentioned the soffit level or ceiling?
No, it will be
False
clear
ceiling.
height. It will be clear
Yeah,
height, like
full height.
from full height, because
Okay.
your even though if you take return, okay, that return will go above the space, right, above the false ceiling.
Yes.
So still you have a heat. Okay, so
Okay.
that means you have to calculate for the entire space.
Okay.
Clear, right?
Okay, doctor.
If you go with the ducting system, say for example you have a supply ducting and return ducting, then you can take below the ceiling.
Okay. Okay.
Okay, but if you go with the like open return, then you have to calculate the entire ceiling height
Full
because
height.
the heat will be transferred everywhere. Okay.
Okay. Okay.
Okay, so this is the space input. Okay, we have seen general, internal, walls, roof, infiltration, floors, and partition, right? Okay, next we are going to see the system. So if I enter the system, if I double click here, I can able to see general, system component, zone component, sizing data, equipment. Okay, so if I go to general, you are going to enter what is the type of equipment, whether fan coil unit or AHU, whatever the types. Okay, then you are going to enter the chilled water air handling unit. Okay, what is the type of unit? It's not only chilled water air handling unit. You can go with the split unit or you can go with terminal units, whatever the type you want to select, right? Then it's always single zone, okay, because you are calculating equipment for each and every zone, right? Say for example, if you go to my input data sheet, okay, you are calculating HAP calculation for each and every space. So you are considering as a single zone. You are not adding everything mixing. Okay, so maybe your each and every zone will have a different temperature, right? So that is why you are going with a separate single zone. Okay, then when you come to the system component, you have ventilation air requirement. Okay, so ventilation air normally whether we have to see whether it is a treated air or non-treated air. Okay, so the ventilation air we will see in detail in the ventilation calculation, but as of now you can just click. Okay, that this will not have any impact. Okay, this is only for control purpose only, right? Okay, next you have a central cooling. Okay, central cooling, you are going to enter the supply temperature 14.4 degrees Celsius. Okay, so this is the coil temperature, right? So I will tell you that how to calculate supply temperature in different classes, or I will send you one video. Okay, how to calculate supply temperature. Okay, why the value is 14.4 degrees Celsius. Clear, right? And recently I have released one video for bypass factor. I think hope everyone has seen that, right? What is the bypass factor? It is the percentage of amount will be escaped between the coil. Okay, it will not flush with the chilled water coil. Okay, whenever it flush with the chilled water coil, it will having a heat transfer. But if it escapes between the coil, that means the hot air is directly entering into the space without adding any heat. So there will be some percentage of air will be escaped. So that is the 10 percentage, like 0.1. Okay, you can ask me any doubt wherever you have a stuck. You can ask me, I can clarify. Okay, then the cooling source will be chilled water. You are going to calculate for the entire month, right? Okay, then you are going to central heating. If you are going to have a heating, okay, so heating, what is the design temperature, what is the type of you are going to use, whether electrical resistance or hot water or steam, how you are going to heat, right? And you are going to calculate from schedule January to December. Okay, but in this region in UAE we are not considering any heating because heating is considered only for like European countries or where the cold countries. Okay, that is why if you go to local regulation, they consider only summer temperature, not winter temperature, right? Okay, when you go to supply fan, you have which type of fan you are going, right? Depends upon the capacity, forward curve or backward curve. Remember, I have sent one quiz, which is the most efficiency. So aerofoil or backward curve will be the more efficiency, right? Okay, then the draw through or blow through. Okay, depends upon the blower orientation. Then what is the Pascal? Okay, static pressure, expected static pressure, because that will affect your cooling load. And what is the efficiency of the machine? You can able to input all the parameters, right? Then go to zone component. Okay, space. The studio, you will take that space into the zoning. Clear, right? Then the thermostats, what temperature you're going to set, whether 22 or 23, you can able to enter the value here. What is the design temperature, right? So if your design temperature, assume that your design temperature will be 24. Okay, then what you can do, you can go to this value, you can enter 24 degrees Celsius. Clear? Okay, then the sizing data. Okay, what is the chilled water temperature, on coil and off coil temperature? You will study in future, you will understand that what is the chilled water coil temperature, what is the supply temperature, what is the return temperature, what is the delta T. You will going to understand in future, right? And what is the safety factor as per the regulations? If you go to regulations, they have given here 10% and 5% for the safety factor. So this is the safety factor you are going to enter here, 10% and 5%, right? So when you click here, okay, you are finished with the system component. Okay, so we have done with the weather properties, then we have done with the space, then we have done with the system. Okay, so when you enter here, when you click, you will get the result. So this result will be calculated for the total cooling coil, then your sensible coil load, airflow rate, then your coil ADP, then your leaving temperature, what is the entering temperature, what is the outside temperature, okay, the load acquisite, what is the maximum considered, okay, what is the peak temperature considered, right, and what is the design supply temperature, okay, and if you have a heating, what is the heater temperature, heater capacity, okay, if you have outside air, what is outside airflow rate, okay, and fan power, because we have given static pressure, right? And if you go further down, here you will see the type of loads, okay, from here, like a window, sky load, how much it is, wall transmission, roof transmission, window transmission, skylight, door loads, floor transmission, partition, ceiling, task lighting, people. So here it is a mixing of internal load and external load, right? So what I said before, you are going to calculate total loads, which comes from internal and electrical and external, right? So that will be the total load. So this is your total sensible load, okay, and total latent load. So from here you will get the total system load. Okay, so this you can see that there will be savings in the ventilation. Okay, there is a ventilation also 410 load, right? So this is also additional load. So when you calculate all together, it will be 2771 kilowatt from sensible and latent 486 watts. So the total load will be approximate 3.3 kilowatt. Okay, so from this result, you can able to calculate your schedule. Okay, so schedule consists of what? Total load. So 3.3. And what is the sensible load? 2.8. What is the airflow rate? 212. And what is the air on coil temperature? 26.2, 19.1. What is the air off coil temperature? 15.4, 14.7. And what is the chilled water flow rate? You can able to give from here, right? 0.11 liter per second. That is the chilled water flow rate. Clear, right, Anand?
Yes.
So
yes,
this is the way we prepare our HAP calculation report. So I request everyone to practice from your side. Take one of the room and start calculating input data sheet, which consists of total load. The input data sheet, which consists of what is the lighting load, what is the equipment load, what is the number of people, okay, and what is the floor area, what is the height of the room, and what is the U value for partition wall, external wall, roof. You provide all the input data sheet, right? So if you provide all the input data sheet from here, you can able to extract the values. It is very easy to feed the data in the HAP software, right? So once you feed all the value, then you can get the result. So this result, how it comes? Based on internal load and external load. Okay, we have seen that manually how to calculate internal load for people, for lighting load, for equipment load. Everything we have seen based on the methods, right? So now you have better idea, because if you go directly HAP, you will not able to understand. You will just you will see like blind. Okay, how this value came. But now you have a better idea how to calculate the sensible load for the equipments. This is the way to calculate heat gain of the equipment plus cooling load factor, right? And for the lighting load, this is the input like watts from electrical panel multiplied by lighting use factor, okay, multiplied by lighting special allowance factor, multiplied by cooling load factor. So whatever the value comes from the HAP software, okay, from this software, you can see that value here, window transmission 199 watts. So how this value came? By using that calculator, by using that formula, equation, right? So whatever we have used, whatever we are using as a HAP software, it is just a calculator. Okay, we are going to feed the data, you are going to enter the result, you will get the result. Okay, that result come by how it came, by means of the equation. We have seen different equations. Okay, so this is the way to calculate your equipment schedule. Okay, this is the way to calculate your HAP result. So this is the procedure to get equipment capacity. It's clear, right? Anyone have doubt?